Hey folks, welcome back. Last episode, we set up the first parts of our save game system where we went through and we could save actors, locations, and certain other bits of information. As you can see here, we saved our location, but one thing that isn't being saved is our stat line component information. As you can see, the hunger, thirst, stamina, that is staying where it was. So in this episode, we're going to work on that. And I want to preface this episode with an admission or just some information. But I know the method we're going to be covering in today's episode is likely not the best method to be using. However, it's the only method I've been able to get to work consistently. I've tried some other methods and I haven't been able to get them to work properly. So, with that out of the way, we will get things started. So, the very first thing we need to do is we need to actually create a utility class. And what that is that's basically just a similar to a blueprint function library, but it's something we're going to be using at a code level. To do that, come into your C++ classes and then your project folder, and we're just going to work straight from here. So we're going to go right click, new class, and we want none, an empty C++ class with default constructor, or there's even the U object. Bear with me here. I want to double check what method I used in the last attempt before I say that. I believe it is actually the none. So we're going to start with that. And in this case, it's going to be a public class. And I'm just going to TF for the fall in this case, and then utils. And we're going to create that class. Okay, so it does create a few things we don't need. However, that's not a problem here. The header file is all we really need. So as I was running that, running the editor outside, I hadn't launched it through Visual Studio. I'm just going to let things finish there, but we can start working on our code. So the first thing we're going to do is in the source file, we're just going to remove the default constructor and deconstructor and save that, and then we can close that. And then over here in the header file, we can actually remove, we're going to hit reload all, so that actually pulls it in. Close back out of the source, and then the header file, we're going to delete everything but the pragma once and the include core minimal. It's the only thing we need to include in here. So I'm going to close out of live coding, and now that that's popped up, I'm actually going to close out of the editor as well. Just get content browser out of the way if it lets me. Come on. Nope. All right. Well, I'm just going to leave that running. So what we're going to be doing in this class, well, it's not even really a class, it's a function library, is going to be using and creating utility functions. And these are going to be things that are usable in pretty much any case that you want, or any place that you want, and you want them to be used, or they're going to be used in multiple different areas. So this first function we are going to be creating is something, it's a string chop function, chop string, and this is going to be used as part of our, well, actually in this case it's part of our load functionality, but it's also, like, it can be used in other places as well. So we want f string source, if I could spell, char split, and I'm going to give this a default value. Are you going to stop? Oh, I can't even use the right casing, or right. There we go. I was using that as a text, not a char. Okay, so T array f string ret and f string push, and then for int I equals 0, I less than, I want to treat this as an int source dot length, I plus plus. So what we're going to be doing here is we're going to be stepping through each individual character in this source string, and we're going to be looking for this specific character. So if source I is equal to split, we want to take ret dot add push, and then we want to clear out push dot empty. Else push plus equals source I. If source, or sorry, if I equals source dot len ret dot add push, and then return ret. So just quickly to run through what this function does, we'll actually just do it up here. We're going to say you send in this string into, like, that is your source string. What that is going to do is it will output an array of val1, val2, and val3. And we're going to be using that as part of the save system for our statline component. And this is something I actually use myself. It's a helper function I've used for quite some time in my professional life with development. Obviously, it's not using the Unreal formatting of T arrays and F strings. It uses vectors and strings and everything like that. But literally, it's iterating through. It's like, okay, if this character is the character we want to split, we're going to grab everything that we have in the push here, add it to our return, and then we're going to move on to the next character, so on and so forth. So now that we've got this helper function put in, we can actually go back to our statline component here so we can get things working there. So what we need to do is add something to this struct, and that is it's basically a save string function. So it's f string get save string, and this one is pretty simple. Again, like I said at the start, this is not the best solution. I know there's going to be something better out there. However, this is a solution that I have had work for me every single time. So we want f string ret equals f string, and if I get my capitalization right, sanitize float current ret plus equals, we're going to add our split character. I'm going to just copy that because we're going to add that again. Ret plus equals f string sanitize float max. Add in our separator, and ret plus equals f string sanitize float per second tick. And then we want to return ret. And then we want to add one final helper function here into our struct of void update from save. Now you could go two different ways with this. You could go tarray f string parts, or you could pass in just a string and separate it within the function itself. What I'm going to do is just this tarray, because then we don't need to worry about adding in calls to that utility function within the structs logic. We can do that within the source file instead of the header file. So, and right now we know parts should be 3, so we're going to add in a failsafe. If parts.num does not equal 3, to do log error return. Otherwise, current equals fc string atof pointer to parts 0. Max is parts 1, and per second tick equals parts 2. So quickly, just to run over this. So as I mentioned, we've got our generate save string, and then we've got, actually we're going to update from save string. So if parts doesn't equal 3, so if for some reason we're passing in an array that is 1, 2, 4 or more, or 0 for that matter, parts, we don't want it to do anything because it's going to cause some weird behavior. So we've got the failsafe here. If it doesn't equal 3, we want to log an error once we get to logging, and then we want to just bail. Otherwise, we want to set the values based off this. So those are the changes we needed to make to the struct. Now we actually need to make some changes to our save actor data struct. So we're going to go to the save actor interface up to the top here, and we actually need to add a new struct in. So at the very top, just below your includes, go use struct blueprint type. As we know, we want this accessible to blueprints. So struct f save component data. I holding enter instead of shift. Generated uStruct body. As I mentioned before, and I'll just cover it briefly here, generated body and generated uStruct body are both viable. I used uStruct body for code clarity, and that's it. And just like before with our other struct, we want all of this to be public. And again, we want these to be visible anywhere and blueprint read write. So the first thing we want is a T array of uint8, and we want this to be byte data. And we want the same thing. We want u class component class, and then finally we want T array f string raw data. Now what we also want to do, because we're going to end up having actors that have multiple components, so think your player character, you're going to have, in this case, the stat line component, an inventory component, perhaps a trait component like your skills, things like that. We're actually going to want to add this to our main save actor struct as well. And we're going to add that in right under the byte data. We're going to go T array, again, my casing, F save component data, and we're going to just component data. Yes, I understand I say data weird. I have in my life lived in various different places around the world and have a mongrel accent. It's a mix of so many different things. So anyways, so now we have that added in. We need to make some changes to our actual save actor interface. So we currently have get actor save ID and get save data. We're going to add in a new function, and these are all going to be done in the same format. U function, blueprint native event, the blueprint variant, and then the same thing again with the code level implementation. So we want a brain's not working. Oh yes, so we want a f save component data git component save data. Copy that, and I'm gonna, for ease on my own brain, copy that. Create an implementation of that. And save. And then we want the opposite of that. We want a void, we want that to be virtual. Void set component save data. And that is going to take in an fsave component data. And again, we need the C++ implementation of it. And then, let's see. All right, so that is the main ones we need there. So now we're going to go back to our game instance. In here, we need to now add some logic in to gather the component data. And we're actually going to do that right here after we've serialized the main actor information, but before we add it to our save structure. So what we need to do here is another for loop. So in this case, for, and I'm just going to go auto, what you call this? So it's actor comp, and this is actor.get components. And what this is going to do is it's going to iterate through every single component that is on the actor. And we're going to want to do something similar to what we did here. So we're going to go if actor comp implements, and that is a usave actor interface. And if it doesn't, we just want to continue. Knowing that it does, and we don't just, actually I'll step back here for a second, we don't need to worry about this is valid being done down here, because individual components at this point should not be invalidated between here and here. So that's why I'm not including the is valid. We're just looking to see, does it implement the interface? If it does, we want to go I save actor interface pointer comp inter equals cast I save actor interface, and this is actor comp. So now we've got that. We do want to just add in if comp inter equals null pointer. We're not logging anything on this, so continue. Otherwise, we want to move on. So now we need an fsave component data. Save comp data. Save component data equals comp inter get component save data implementation. And then we want to go fmemory writer comp mem writer, and we're going to go scd dot byte data f object name and string proxy archive car, and we're going to put in the comp mem writer and true. And then we're going to car.ar is a save game equals true. And then we're going to go, what are we calling this? Actor comp serialize AR, CAR. And then we're going to go scd dot component class equals actor comp get class. And then, yeah, we're just pushing that back into, what do we call it? SAD. SAD.componentData.add SCD. So what we've done here, just to run through this quickly, is while we're getting the actor information, we are looking through all of its components. If those individual components need to be saved, or in this case don't need to be saved, we just move to the next one. If it does need to be saved, we get a reference to its interface. If for whatever reason that doesn't work, we move on to the next one. Then we have it, then we call get component save data implementation. From that, we serialize everything we can within the component. We push that back into our save component data struct. We add that into the actor's save information, and then ultimately we push all of that into our save array. Now we need to load that information, so we do need to make some changes there as well. So we're going to go to our load game function. We're going to expand this out. And this is something we'll be covering at later in this episode of setting the actor GUID. So this is where I mentioned last episode we were going to need to add in some custom logic. So that's what this section is for here. So what we need to do now, pretty much the inverse of what we just did. So we're going to go for auto actor comp in actor get components. If not actor comp implements I save actor interface, or is it you? Oh, my brain's not working. No, it is the you save actor interface. Continue. Don't worry about doing anything else, just move on to the next one. If it does, we want a I save actor interface pointer for comp inter equals cast I save actor interface actor comp. If comp inter equals null pointer, if I could spell, continue. Otherwise we want to pull up what I did before. I want to make sure I'm doing this correctly. Because I had some refactoring I wanted to do on this one. Okay, yeah, so just to cover, what we're doing here is we're checking each of the individual components that are on the actor. If they don't need to be saved, we're moving to the next one. If we can't get their interface, we're moving to the next one. So now that we have that information, what we want to do here is for auto saved component data, and this is, what do we call this? sad dot component data. So now what we're doing is for every single component we have saved in our actors information, we're taking a look at those. And if SCD does not equal actor, no, let's go back. FCD dot class component class does not equal actor comp get class, continue. And this is the same thing here. It's like, okay, do these match? If they don't, okay, we don't need to worry about that component. If they do match, we now need to do some additional logic here. So we want an fmemory reader, and this is going to be comp reader, comp mem reader for clarity. And we're going to go, this is scd dot byte data, and then it's f object and name string proxy archive component ar comp mem reader true ar is save, no, ar is save equals true. And then we want to go actor comp serialize car. And then after we've done that, we also need to see is the, let me just pull that back up so I can reference it, is this information holding anything? So if scd dot raw, is that what I called it? Raw data? Yep. Raw data dot is empty. Well, now we don't want to continue. We actually want to, because continue would go through this again. We actually want to break. And what this break is going to do is it's going to drop us out of this for loop, and we're going to go from here to this point in the code, which is actually then just going to go us back through this loop. If it's not empty, however, we do want to now do some work with that. So what we're going to need to do here is get a reference to, sorry, we're going to want to add, actually I've done this the wrong way. No, that's right. Comp enter dot set. Is that the one I want? What did I call it? Oh, no, we never added this function. So, no, we did. Set component save data. That's what we want to do. Set component save data implementation, and we're just going to pass in scd. And then what we're also going to want to do here is break. And the same thing here is that's going to say, okay, this component has got its save information. We're going to go through. Now, there is one thing I want to also address here and fix quickly, because I just realized there's a bit of a flaw here. This is something we'll fix later on. I just want to add this in, and it was actually in my notes from my previous version of this. Let's add it right here. So, my formatting didn't work because my tab indexes are off. So just to cover what this is all about though. So one thing is, if for whatever reason you happen to have two identical component classes on one actor, you're going to have a conflict, and only one of those is ever going to get saved, updated with a save. That is something that realistically you should never have happen. However, it's something to bear in mind, the way this has been done. Now, one possible option is GUIDs. However, you run into the problem with your spawned actors that we have up here. Well, now you're having to set GUIDs for a bunch of different things, and it gets really complicated at that point. So, I have this as a note for myself. That is quite literally not safe if an actor has two of the same components that are saved as the list. First component returned by the actor get component will get all of the data. That's actually not 100%. It's actually opposite. So, but anyways, so now we've got this functionality done. We need to actually go through and update our statline component to correctly handle these. So let's close out of a bunch of these other files that we no longer need. We'll keep the game instance open. Actually, no, we don't even need that. So we need the save actor interface and the statline component. So what we need to do is first and foremost have the statline component inherit from the save actor interface. So we're just going to bring that in. Copy U, statline component, add that in, and public save actor interface. And now that means we are going to need to include these. So we're just going to copy these over quickly down here in the bottom of the public section. Now you could go through and create a separate interface that's save component interface. However, I wanted to keep all the logic in one place specifically and not have to worry about having multiple interfaces, one for actors, one for components. It does mean a lot of this information is going to be, these functions are going to be useless, but it's not a huge problem on our side. And actually, I just realized I didn't make that virtual either. So now we've copied these over, we can say, well, we don't need these two. So we're going to quick reference these. Quick action refactoring, create the definitions. So we now have the function definitions for those. So let's start working on that. So I just want to quickly make sure I'm looking at the right ones. My old project had multiple iterations of these. Okay, so this one is a little messy, but it's, again, as I mentioned at the start, this is the only way I was able to get this to work reliably. And get rid of that. So we want ret, just like with everything else. We'll just add that in here so it's easy. So ret.component class equals this get class. ret.rawdata.add health get save string, and you can imagine we're gonna have to do this. ret.rawdata.add stamina get save string, and I'm actually gonna, for ease, I'm just gonna do this. Hunger and thirst. Now, something that is important to remember with this is these are all going to be in a very specific order. So that's index 0, 0, index 1, index 2, index 3, and then this is a note. Any additional raw data adds here need to be included in the set component save data notation function. So what this is this is for anything that's not being saved with serialization. And I can tell you the custom structs we created aren't. Anything we add here, we need to add in a similar process here. So now we're going to work on that one. So we're going to want to do this T array F string parts. And no, as I mentioned, this is not efficient. There is going to be a more efficient way for this. However, it's, like I said, it's how I got it to work. Data dot raw data dot num I plus plus. So parts dot empty. We want to make sure that array is emptied every time we iterate through this. And, oh yeah, this is where we want to include tf utils. All right, and then we want to go parts equals data dot raw data I actually equals chop string, and though it has a default, we want to just pass that through for ease. So what this is doing is we're taking that and we're splitting it into the individual strings. So it'll be the 3 current, max, per second tick. And then we want to do switch on I, case 0, case 1, case 2, case 3, and default. Case 0 is health dot update from save string parts. Then it's stamina dot update from save string parts. Hunger dot update from save string parts. Oh. Break, add these in, otherwise it's gonna do some really funky stuff. And a thirst, update from save string parts. Default log error with log error, and just want that to break. And then we're done. So what this is doing, actually I'm going to build while I run through this. So what we're doing here is we're taking in, oh, we've got a fail, I'll fix that in a second. Oh, live code is still running because I still have the editor up. I forgot to close it. So anyways, so what we're doing here is we're creating an array of the save strings for each of the stats we're containing. That's getting saved as part of the actor data within the save game file. And then when we're loading it back in, it's like, okay, we've got all the serialized information. So some of this could be and OBS and my game system just decided to lose a monitor. Either way, so with this, like I've tried, as you can see here, we have that save game attribute. It's not being serialized, and it's up here. It's not being serialized. There is additional functions, like you can do the farchive operator stuff. I never got that to work. So, as I mentioned, I have this working. If I find a better way to do it, we'll update that further through in the series. But okay, that should be long enough for that to build. And I'm going to quickly fix my display. Or not. Okay, well, while that builds, I'm going to pause things here, and I will be back once the build is done. All right, folks. The build completed, but it did throw an error. I did take a couple seconds to figure out what it was. For whatever reason, I'm not sure if this is something unique to 5.4 or if it's something that I did differently, but the error is the fact that we've defined this in the header file. So we're going to quite simply cut that out, turn that into just a function declaration, quick action, create the definition. It's going to take us over to the source file. It's going to define that there, and we're going to build. And this time around, it builds fine. So what we're going to do here, though, before we launch the editor, we're going to throw in 2 breakpoints, one on the get component save data and one on the set component save data. And then we're also going to go into the game instance itself, and we're going to throw 2 breakpoints, one for at the gathering the information about components, and the other one is going to be when we're setting the information about the components. So now we've set those, we're going to launch the editor from Visual Studio or your IDE of choice, and I will be back as soon as the editor is up. All right, so the editor is built. I'm actually just going to move the content browser out of the way, and we're going to hop straight in here. So we're going to go do the same thing we've been doing before. We're going to move our character to a place and hit save. Hops into Visual Studio. So I'm going to add a watcher to the actor comp variable. Right now it's been optimized out of the way. Collision cylinder, and I'm going to throw another breakpoint there. So I'm going to continue. Arrow, character move component, character mesh, stat line. So here we go. We're now looking at the stat line. Does it implement the save character interface? Yes, it does. Did we get the interface? Yes, we did. So we're going to get component save data. And now this hops into the other breakpoint we've set. So we create ret, and then we set all these variables. So we're going to say ret.raw data. That's fine. We're going to hop out of this. Now we're going to look here. In the raw data, you can see we have 4 entries: health, stamina, hunger, and thirst. And you can see it's storing the current value, the max value, and the per second tick. And the reason for that is that we're doing things like the per second tick, things that would be defaults, the max as well, is you could have buffs, you could have status effects in your game that affect those values, and you want those to be present right at the very start. So, like when you load in. So we're going to do that. We'll skip to after the serialize, and we're going to take another look here. And you can see byte data has a bunch of information in there. Stamina, struct, properties, core stat, script, fall, current. It's a float property. And I'm not sure if, but so anyways, now we push that back in there, and you can see we're now going to go through, and I'm actually just going to continue and drop these breakpoints. So we've saved that. Now we're going to go through, I'm going to move over here. Our stamina was almost full. I'm going to bring us over to this corner, and we're going to hit 9 to load the game. Same thing. We're looking at the collision cylinder, and I'm going to put that right there. Arrow, character move component, character mesh, stat line. So does it have the save interface? Yes, it does. And we're going to look in here at the component data. You can see there is one stat line component, actor component. Oh, there we go. That's something I've noticed with Unreal Engine when you're debugging. Sometimes it'll bounce back and forth before it gets to the next actual step. So we're going to deserialize, and we're actually going to look at this quickly. before we apply, because we may not actually need this additional information now. So actor component. It's under this one here. Nope. This one. No. Where would stamina and those other variables be? No. Well, in here, I'm not going to waste any more time on this episode digging. So we've gone through here. Is raw data empty? No. So we're going to do that. We're going to hit our next breakpoint. And we've just got that whole struct coming through. Actually need changes to a reference. Parts. So for the first one, I equals 0. Parts empty. So you can see parts is empty. And that comes back to... Oh. Maybe I've got a flaw in here. It's only showing 2, because now we're going to Shift F11. There we go. We're only getting 2. What is happening there? So okay, let's see. So I is 2, so we are in the third. So what is not happening there? Parts is only getting the 82 and 100 when it should be getting 82, 100 and minus 2. Okay, that's interesting. So we're going to continue here. I'm going to drop these breakpoints. But you can see the values are returning. I wonder if that's just something with the way things are being optimized. So we're going to get rid of these breakpoints so we can just see that in actual editor. So let's see. Yeah, they are restoring properly. So that may just be something weird with the debugger. But anyways, folks, this episode has ran on a little longer than they expected. With that, we have done the very basics of our stat line and our save game functionality. There is one other change I want to make, which we will be covering in the next episode. And that is going to be, well, not even a change. There's one change I want to make, and there's also one additional item I want to cover. That is going to be uniquely saving the player character's information. And then also, as we glossed over at the start of this episode, or earlier in this episode, we do need to address this functionality here for setting an actor's GUID when we have to spawn one in. But as I said, we'll be covering that in the next episode. Thanks for watching, everyone. I hope you enjoyed. As always, any comments, questions, or suggestions, please feel free to add them in the comments below, and I will see you in the next episode.